Okay, this is lecture 10. Welcome. Just a reminder of the remaining of the term work. We just did our midterm test 2. The class average is 70. Standard deviation is 10. We have one final exam left. That is was 40%. 40%. Final exam is on Tuesday, June 13 at 6 p.m. The format of final exam is similar to test 1 and test 2. It is online test on D2L, okay? And do not forget, we also have 24% MyLab, 24% MyLab. The due dates is on MyLab. You can also check out the due date on Brightspace under course material. MyLab due dates. Okay, MyLab due dates. So the last few modules would be due June the 12th. June the 12th is module 9, module 10, module 11, and module, do we have module 12? Module 12, okay? Last 4 modules due June 12, just one day before our final exam. Okay, so that is the due date. Any questions? Try to track down the, oops, sorry. Okay, any questions? Any questions? Okay, you are welcome to type in your questions in chat area or directly speak up. Okay, so that is the remaining of term work, final exam, and few MyLabs. So today we are going to do geometry series. After today, our next lecture is lecture 11. In lecture 11, I will combine lecture 11 with lecture 12. So lecture 11 is all about simple interest and compound interest, okay? So simple interest and compound interest will be in lecture 11. So today is a geometric series. We are going to go over the PowerPoint presentation as usual. And then I will go over the tutorial for this lecture. Okay, stop me for any questions. Okay. So first concept is the sequences. So if you consider the function fn equal to 2n plus 1, so when n equal to 1, you get f1 equal to 2 times 1 plus 1 equal to 3. When n equal to 2, you got f2 equal to 2 times 2 plus 1 equal to 5, etc. Okay, so this f is an example of a sequence. Is an example of the sequence. So the general format. So we usually use A1 represent the first item, A2 represents the second item. So the nth item we use AN. So in this example, AN equal to 2n plus 1. So this is the sequence. So we already did that. Now let's look at the example. Example 1. Write the forms of our sequence. I have one new student just joining in. Hello and welcome. Just update on you. We are doing lecture 10 PowerPoint presentation. After this presentation, I will go over tutorial 10. Okay. You can find this PowerPoint slide on D2L. Okay, write the full terms of the sequence. So if you have AN equal to 3n minus 2, you are asked to write down the first 4 terms. So for this A, you are asked what is A1, what is A2, what is A3, what is A4. So to find out A1, just plug in n with number 1. So 3 times 1 minus 2, which is 1. And A2, it is 3 times 2 minus 2, equal to 4. A3 equal to 3 times 3 minus 2, 7. And A4, 3 times 4 minus 2, equal to 10. So this is A. Questions? Now let's go over B. For B, we also need to find A1, A2, A3, A4. So A1 means when you see n, you place with 1. So negative 1 raised to power 1 over 1, which is negative 1. And A2 equal to negative 1 raised to power 2 over 2, 1 over 2. A3 equal to negative 1 raised to power 3 over 3, negative 1 over 3. And A4, negative 1 raised to power 4 over 4. It is 1 over 4. So that is B. Okay. Questions for the terms of each sequence. All right, so let's move on. Series and summation notations. So what is a series? If A1, A2, AN is a sequence, then if you add all the items, this one is called series. As you can see, it is different between series and sequence. So A1, A2, AN, this one is a sequence. When you add all the items in sequence together, it forms a series. Okay. So for example, 1, 3, 5, 7, 9, this is a sequence. If you add all items, all the terms in sequence, you get a series. Okay. And next, let's introduce summation notation. Summation notation is a compound form to represent addition. You see many additions here. So we use sigma. Sigma represent you add all the items together. For example, sigma k squared, k from 3 to 6 means k equal to 3, you got 3 squared. K equal to 4, you got 4 squared. K equal to 5, 5 squared. K equal to 6, you got 6 squared. Okay, so you got k squared. Let's look at another example. 4k plus 1, k from 0 to 2. So from 0 to 2. So let's start with 0. When k equal to 0, you got 4 times 0 plus 1. When k equal to 1, you got 4 times 1 plus 1. And when k equal to 2, you got 4 times 2 plus 1. Okay. So that is the summation notation. Any questions? All right. Now let's talk about arithmetic and geometric sequences. So first, definition of arithmetic sequences. If you have a sequence A1, A2, A3, AN, this sequence is called arithmetic sequence if you can find a constant D, this D called common difference, such that the term N minus the term before it, before term N, you get N minus 1 equal to D. In another expression, AN equal to AN minus 1 plus D. Okay. So for example, I give you example. 1, 3, 5, 7, 9, etc. This is an arithmetic sequence. This is an example of arithmetic sequence. In this sequence, I got A1 is 1, A2 is 3, A3 is 5, A4 is 7, A5 is 9. Okay. If you use the second item 3 minus the first item 1, what you get? You get 2. And do the same thing, use the third item 5 minus the second item, you got 2. And next, use the fourth item. The fourth item is 7 minus the fifth item, you got 2. See, every time when you do the subtraction between two adjacent numbers, you get a constant number D. We call this number is D common difference. Okay. So this is an arithmetic sequence. When you have the common difference between two adjacent terms. Now next, geometric sequence. When you do the ratio between two adjacent terms, so AN over AN minus 1, you got a constant number, R. This R is called common ratio. Okay, and that sequence is a geometric sequence. Okay, for example, you got 2. Etc., etc. This sequence is a geometric sequence because the ratio between two numbers are constant. Let's verify. So 6 over 2 is 3. 18 over 6 is 3. 54 over 18 is 3. And this 3, we use little small r called common ratio. This is common ratio. Okay. Okay, questions? All right, let's move on. Let's do this theorem 1. Nth term of arithmetic sequence an equal to a1 plus n minus 1d. Okay, so this is the property of the formula, and this formula is very important. The nth term of arithmetic sequence. Okay. For example, I give you an arithmetic sequence here, 1, 3, 5, 7, 9. I will use this example again. 1, 3, 5, 7, 9, etc. So this is A1 is 1, A2 is 3, A3 is 5, A4 is 7, A5 is 9. So let's say A5. A5 based on this formula equal to A1 plus n minus 1. So how many items up to 9? 1, 2, 3, 4, 5. Okay, n equal to 5. And what is D? D is the difference between adjacent numbers. So 3 minus 1, that is D, is 2. So in this example, D equal to 2. Okay, so A5 equal to A1. A1 is 1. See this A1 is 1. 5 minus 1 is 4. 4 times 2. So you got 1 plus 8 equal to 9. See, A5 is 9. We verify this formula. Okay. So this is the nth term of arithmetic sequence. And the theorem 2, nth term of geometric series, an equal to a1 r n minus 1. So I will use this example I just gave you. 2, 6, 18, 54. So 2, 6, 18, 54. There are many other items. So in this sequence, A1 is 2, A2 is 6, A3 is 18, A4 is 54. Suppose you don't know A4. You are asked to calculate A4 based on this formula. So this formula said A4 equal to A1 times Rn minus 1. What is A1? A1 is 2. Here, A1 is 2. And what is R? R is the ratio between two adjacent numbers. So R equal to 6 over 2. These two numbers adjacent. Okay, so equal to 3. And what is N? N equal to 4. So you plug in the given number. A1 is 2, R is 3, N is 4. 4 minus 1. So you get 2 times 3 raised to power 3. 2 times 27. You got 54. Bingo, you verified. A4 equal to 54. Questions? All right. Now let's explain theorem 3. The sum of finite arithmetic theorems is this formula. This formula. So let's do an example. This example, again, I will use the example I used before. So 1, 3, 5, 7, 9. So if you want to add the first 5 items, so you are doing S5. So F5 equal to n equal to 5 in this example, n equal to 5, and then bracket 2a, 2a1, a1 is 1, a1 is 1, plus n minus 1, n is 5, n is 5, so 5 minus 1 times d. D is the difference between adjacent two numbers. So in this example, d equal to 3 minus 1 equal to 2. So times 2, times 2. So work out this expression, you get 5 over 2, and then 2 plus 4 times 2h. So 5 over 2 times 10, you got 25. Okay, so if you add the first 5 items together, you got 25. You can verify. So if 1 plus 3 plus 5 plus 7 plus 9, you do the addition, the result must be 25. Okay, and this sum we call S5. And this is the first form. There's another form for arithmetic sequence. For the sum of arithmetic sequence, it is Sn equal to n divided by 2a1 plus an. Again, let's use this one as example. 1, 3, 5, 7, 9. Let's use this as example. Okay. And in this example, n equal to 5. A1 is 1. A5 is 9. Okay. So we want to do all the 5 items and together. So S5 equal to n divided by 2. A1 plus A5. Okay. So you get 5 over 2 times 10 equal to 25. The same result as we get here. Okay. Questions? Right. This theorem 5 is about sum of geometric series. There are 2 forms, the first form, the second form. So let's look at the first form first. If you add all the n item for geometric series, it is this formula. The first item A1 times r raised to power n minus 1 over r minus 1. So what is r? R is the ratio between adjacent terms. Okay, so r is an over an minus 1, that is r. And you can use the second form, is this one here. The second form, just use a1 an, see a1 ani The first form just use A1, R, and N. Okay, questions. So those are just theorems. The important stuff we need to use those theorems to do the problem. Okay. Theorem 7 is the sum of infinite geometric series. Sometimes a series goes forever. It goes forever without ending. That is the infinite geometric series. If a series goes forever, the sum is use this formula. It is just the first item over 1 over R. Okay, let's look at example. Economy stimulation. The government has decided on a tax rebate program to stimulate the economy. Suppose that you receive 1,200 and you spend 80% of this. And each of the people who receive what you spend also spend 80% of what they receive. And this process continues without end. That indicate this is an infinite theorem. According to multiplier principle in economics, the effect of your 1,200 tax rebate on the economy is multiplied many times. The question asks you, what is the total amount spent if this process continues as indicated? Okay. So I pause for a moment, let you digest what is given, what you are asked to do. Questions? So this question asks you to find the sum of an infinite geometric series with the first item is 80% of 1,200. The common ratio is 80% because each person get the money will receive 80%. So you identify A1, the first item, you identify the common ratio R, and then you use the formula, the formula for infinite theorem. It is just the first item over 1 minus R. The first item, 980, R, common ratio 0.8. So the final result, 4,800. So the implication of this problem is that if one person, you are the person who get 1,200 tax rebate, because of the multiplier principle in economics, it will result in 4,800 in spending. Okay. So that is the infinite theory, the sum of infinite theory. Any questions? Right. Okay, so let's this is just a summary of what we have learned so far. What is a sequence? A sequence is just an ordered list of numbers. For example, 1, 3, 5, 7, blah, blah, blah. That is a sequence. An arithmetic sequence is the number. It is the number can be obtained from preceding one. So for example, the next number, you You can guess it is 9. Next one, 11, 13, because you know the difference is 2. Each time you add 2 to the previous number, you get next number. Each time add 2 to the previous number, you get each number. And this D is called common difference. Common difference. Okay. In arithmetic sequence, you have term an equal to an minus 1 plus d, or an equal to the first item plus n minus 1 times d. And the sum of n terms, it is this formula, commonly used, this formula. Okay. Questions? Okay. For geometric sequence, we call R is the common ratio. What is the definition of R? R is the ratio between two adjacent terms. Okay. So an equal to R times an minus 1. Another formula for an, it is a1 times R raised to power n minus 1. The sum of n terms equal to this formula. It is actually a1 1 minus Rn over 1 minus R. So this is Sn. Okay, questions. In infinite geometric theorem, the sum of the term is just the first item a1 over 1 minus R. Okay. The absolute value for R is smaller than 1. So that is the PowerPoint presentation part, and this is the summary of this lecture 10. Any questions? Any questions? Okay, so now we are going to do the tutorials. So focus on problem solving, go question by question. You can get the tutorial on D2L. So tutorial 10. Tutorial 10. Let's do question 1. Let's do question 1. Question 1 asks you to find the nth term of arithmetic sequence. So you are given A1 is 2 pi over 23, A2 4 pi over 23, A3 6 pi over 23, etc., etc. The question asks you, when n equal to 21, what is A21, the nth term? Okay, what is nth term? So you just use the formula for A21. Remember the formula is an equal to a1 plus n minus 1d. That is the formula. Plug in n equal to 21. Okay, you get A21 equal to a1 plus n minus 1d. What is d? D is the difference between two adjacent terms. So D is the second item minus first item. Second item minus first item. That is D. Okay. So 4 pi over 23 minus 2 pi over 23. The result is 2 pi over 23. 2 pi over 23. So once you get D, plug in this D with 2 pi over 23, 2 pi over 23. A1 is 2 pi over 23 here. N is 21 is given. And then you simplify this, you come up with the final result. This is the final result. Questions? Okay, shall we move on to question 2? Make sure you do this by yourself to come up with the correct answer. Question 2. Find the sum of the terms in arithmetic sequence. So what is Sn? So how do you solve for this? So this is arithmetic sequence. You are given some item already. The first step, find out D. Remember what is D? D is the difference between two adjacent numbers. So you use negative 16 minus negative 9, that is D. Okay. Do the difference between two numbers. So once you identify the D, next, how do you know how many items in this series? How do you know? It is 20 items, 15, 25. How do you know how many items from negative 9, negative 16, negative 23, negative 30 until negative 100? How many? So in another word, what is N? N equal to what? So to do that, you use the formula. Remember, there is a formula. An equal to A1 plus N minus 1D. Okay. So we already know An is the last item is negative 100. A1, we know negative 9. We know A1. Then we just solved for D. D is negative 7 here. D equal to negative 7. Okay. So plug in. So N minus 1, D is negative 7. So here you got one equation, one unknown. You can solve for N. So copy down the left-hand side, you get negative 100. Right-hand side is negative 9. So N times negative 7, you got negative 7N. Negative 1 times negative 7, positive 7. Okay, so keep on going. Left-hand side, negative 100. Right-hand side, negative 9, positive 7. It is negative 2 minus 7N. Now, move negative 7N to left-hand side. You got 7N equal to. Move negative 100 to the right-hand side. You got 100 minus 2. Let me double check. Negative 9, N minus 1, negative 7, 7N equal to negative 2. So this is 7n. So we get 7n equal to 98. Okay. 7n equal to 98, n equal to 98 divided by 7 equal to 14. So n equal to 98 divided by 7 equal to 14. We got n. There are n items, so n equal to 14. There are 14 items in this sequence. Any questions? Sorry for my dog. Any questions? Okay, so once you found the term, you found n equal to 14, what is original question? Original question asks you found the sum of the terms. And then you use the formula sum of the term Sn equal to n over 2 times bracket a1 plus an. N equal to 14, you plug in 14. A1 is -9. An is -100. So you just work out this number. This is the final result, -763. Okay. Questions? Questions? I just have one new student joining us. Hello, welcome. Hi, Yusuf. Sorry, we don't have a in-person class today. I know you usually attend in person. Glad you can join us online. Yusuf, welcome. We are doing tutorial questions, tutorial 10. We finished the first 2 questions. Okay. Okay. Questions? Question 3 is a little bit complicated. Need a little bit of work. Maybe shall we take a break, 10 minutes break? After break, we'll do question 3. Okay. Or you want to do question 3? It takes it's a little bit difficult question. Okay, for this is application question, question 3. Okay, questions before we take a break. All right, so let's take a break. Come back at 6:55. To continue question 3. To do question 3. Okay. Okay, see you in 10 minutes. All right. Welcome back from break. Hope you have had a nice break. Are there any questions? Before break, we did the lecture and the first two questions for tutorial. Now let's do question 3. Please stop me if you have any questions. You can type in your questions in chat area or directly speak up. Question 3. A beach has an area of 9,400 square meters, but is eroding such that it loses 50 square meters more of its area each year than during the previous year. If it lost 300 during the last year, what will be its area 8 years from now? This question is a difficulty level is difficult. It is not easy question. It is not moderate question. It is a difficult question. So it is also an application question. So let's analyze this question. What is given? What is we are asked to do? And how do we get from what is given to the result? So the question asks you, what will be the area 8 years from now? Okay, 8 years from now, there are total 8 years. Each year, it erodes. So we need to find out total erosion. Okay, how many area lost? Okay, so from now until 8 years, we need to know what is the total area lost. So year 1, year 2, until year 8. So we need to find out A1, A2, A8. Each A represents the area lost. So the area lost in year 1 plus area lost in year 2 plus area lost in A8, all these 8 years add together. And then the beach right now has 9,400. So we use 9,400 minus the area lost. This bracket represents the area lost. That will be what will be its area 8 years from now. I pause for a moment. So the question asks you, what will be the area 8 years from now equal to 9,400 minus A1 plus A2 plus until A8. Okay. And we know A1, so we need to find out A1, A2 until A8. Okay. So the given number said it lost 300 last year. Last year, it lost 300. And then it also had, it lose 50 more of its area each year than during the previous year. So if last year lost 300, what is this year? This year is 50 more than last year. So 50 plus 300, you got 350. That is this year. And this year we use A1. Okay. So we get A1, this year lost, year 1. And then next year, we use A2 represent next year. If this year you lose 350, Next year, we'll lose 50 more than this year. So 50 plus 350 is 400. That would be next year. And the next year, we use A2. Okay. And then A3. So A3 would be 50 plus 400, 450. Okay. And then we can figure out A4, A5 until A8. But we have another way to figure out what is A8. A8 is just the first item plus n minus 1 times D. What is D? Common difference. The difference between two adjacent items. So in this case, D equal to 400 minus D is already given. This 50 is D. D is 50. Okay. So we know A1 is 350. N is 8. 8 minus 1 is 7. D is 50. So A8 is 700. So once we know A8, we need to find out what is A1 plus A2 plus A3 plus A8. So the formula said it is 2 over n 1 A1 plus A8. N equal to 8. So 8 over 2 A1. A1 is 350. A8 is 700. Okay, and this number we got so this is this number. This is our next 8 years total area lost. But the question not asks you what is the total area lost. It asks you what will be the area. So right now you have this 9400 minus the area you lost. That would be the area in 8 years. So this 5200 is the final answer. Questions? Shall we move on to next question? Okay, question 4. Write down the first 5 items of the geometric sequence. This is geometric sequence. You are given the first item A1, 5120. You are given the common ratio R, 0.25. Question asks you what is A1? A1 is given. It's just 550, 512. No, 5120. So A1 is given, 5120. So what is A2? A2 equal to A1 times R. This is the formula. Okay. So A1 is 5020 times 0.25. You go to 1280. Okay. So next, you calculate A3. A3, you can use this formula. So A3 equal to A1 times R raised to power 2. A3 equal to A1 times R raised to power 2. And then A1 is 5020. R is 0.25 raised power 2. And you'll get This one 320. Okay. Questions so far? Okay, next calculate A4. A4 equal to A1 times R raised to power 3. A1 is 50, 20. R 0.25 raised to power 3. To calculate this one is 80. Okay. And again, A5 equal to A1 times A raised to power 4. So 5120 times 0.25 raised to power 4 equal to 20. Questions? Okay, shall we move on? Next question, question 5. Find nth term of the geometric sequence with the given value. So you are given A1, negative 1844, R, negative 1/2, N is 8. Question asks you, what is A8? So this is geometric sequence. You use formula AN equal to A1 times R, N minus 1. So A8 would be A1 times R raised to power 7. N is 8, raised to power N minus 1. Okay, and then A1 is negative 1844. R is negative 1/2 raised to power 7. So this number will give you 461/32. Okay. Questions? And how do I get this 461/32? I have detailed steps here. So negative 1/2 raised to power 7. First of all, you have negative here, negative here. So negative, negative, positive. The answer is positive. And then you have 2 raised to power 7. 2 raised to power 7 is 128. This is numerator. On denominator. Numerator, you have 1844. Okay. And then you use 4 common factor, both numerator and the denominator divided by 4. So numerator divided by 4, denominator divided by 4. Simplify this fraction, you get 461/32. Questions? Okay. Question 6. Question 6. Found the sum of the first n terms of the geometric sequence with the given value. Given A1, 3645, R is negative k/3, N equal to 8. The question asks you the sum of first 8 terms is. So this is a geometric sequence. The sum for the n terms of geometric sequence is this formula. The question asks you to calculate this formula. So A1 is given. A1 3645. R negative k/3. Negative k/3 here. Raised to power n is k. Then on denominator, you have 1 minus bracket negative k over 3. Okay, and from here, you just need to simplify this fraction. Okay. One way to simplify this fraction, did you see this is negative, negative, that becomes positive. And then both numerator and denominator times 3 raised to power 8. The reason is you want to get rid of this 3 raised to power 8. Okay, to simplify. So the rest of the work is just simplify. The final result, I gave you the answer. This is the final result. This is the final result. Okay. Oh, my dog plugging, unplugging my power. Sorry. Yes. Okay, any questions? Okay, shall we do next question? Question 7, maybe question 8, question 6. I pause for a moment to see if you have questions. Okay, shall we move on question 7? Found A1 and R for geometric sequence with the values given below. So you are given AN is 63, N is 3, SN is 91. Okay, so the question asks you, what is A1? What is A1? What is R? That is the question. Ask you 2 numbers. So to see for this question, to solve for this question, we are going to use 2 formulas. So one formula based on AN. So remember what is AN for geometric sequence. AN equal to A1 times R raised to power N minus 1. And you are given AN equal to 63. So 63 equal to A1 times R raised to power 2 because N is 3 is given. So we get one equation, 63 equal to A1 times R squared. Next, we do another equation based on the formula for Sn. Remember the formula for Sn for geometric sequence, Sn equal to A1 times 1 minus R raised to power N over 1 minus R. Okay. So this is this formula, and it said Sn equal to 91. So you plug in Sn equal to 91. So 91 equal to A1 times 1 minus R raised to power 3. N is 3 given here. Okay. So any questions so far? So now we get a system of equations with two unknown. One is A1, we don't know A1, we don't know R. There are two unknowns, but we got two equations here. So we can solve for A1 and we can solve for R. Okay. So any questions? How to set up systems of equation to solve for A1 and R? So now let's solve for this equation, system of equation. Okay. So I call this one is equation 1. So from this one, you got, so right now we have 63 equal to A1 R squared. From here, I get R squared. R squared equal to 63, or you can solve for A1. Okay. So from here, you got A1 equal to 63 over R squared. And the next equation we get is 91 equal to A1, 1 minus R cubed, 1 minus R. And then remember we have, there is a formula. If you have x cubed minus y cubed, it is equal to x minus y times x squared plus xy plus y squared. Okay. Okay, so we apply this formula. So on the top, you have 1 minus R, 1 minus R squared, 1 minus R, and then 1 plus R, and then plus R squared. This is directly apply this formula. On the bottom, you have 1 minus R. Okay. Question so far. Then you have 1 minus R cancelled out. Okay. So you just have A1 times 1 plus R squared. So this is the second equation. So 91 equal to this. Okay. And now plug in this A1 is 63 over R squared into here. You have A1 here. Okay. So left-hand side, you got 91. Right-hand side, instead of A1, you plug in 63 over R squared. 1 plus R. Okay. And this equation, both sides, you times R squared. So right-hand side, R squared. Right-hand side, R squared. Left-hand side, 91 R squared. Right-hand side, R squared cancelled out. Okay. And the right-hand side, you have 63 times 1 plus R squared. Okay. Now keep on going. 91 R squared equal to 63 plus 63 R plus 63 R squared. Okay. And now collect like term 60 R squared, 91 R squared. So 91 minus 63 is what? 38R squared. Okay, and then move these two items to left-hand side, minus 63R minus 63 equal to 0. So we got here, okay, and then I need to double check something. 91 minus 63, not 38, sorry, it is 28. 91 minus 63, okay. And then you divide both equation, you divide it by 7. So 28 divided by 7, we got 4. 63 divided by 7. And what we get so far is quadratic function. Quadratic function. And we can factor this. So we can factor this 4 is 1 times 4. This 9, this 9 we can do negative 3 times 3 is 9. And then when you do cross multiplication, 1 times 3 plus 4 times negative 3. So 1 times 3 plus 4 times negative 3. The result is negative 9, exactly the same as the coefficient of R. That means this combination is successful. Okay, so we write down R minus 3 times 4R plus 3 equal to 0. And then R equal to 3 or R equal to negative 3 over 4. So there are 2 R, both satisfy the original question. Thank you, Zuzu. You pointing out my 28 R squared. Yes, it is 28 R squared. Okay. Okay, questions? So we solved for R, but we also asked to solve for A. We solved for R. So remember what is A? A is A1 is 63 over R. So A1 is 63 over R squared. Over R squared. So when R equal to 3, so 3 squared. Divided by 9. And then use 3. This is 2, 21. And 3 again. So A1 equal to 7. Okay. So when R equal to 3, A1 equal to 7. Then when R equal to negative 3 over 4, A1 equal to 63 over R squared. So equal to 63 over, oops, sorry. 63 over R is negative 3 over 4 squared. Okay, so it would be 63 over 3 squared times 4 squared. So it would be 7 times 4 squared. Would be 112. So A1 equal to 112 if R equal to -3 over 4. Okay. Questions? Shall we move on to next question? So we just did question 7, okay? So now let's do question 8. Question 8. Question 8. Find the sum of geometric sequence. How do we find this one? You see this dot, 3 dot here. That means this is infinite geometric sequence. And the sum for infinite geometric sequence, it is just the first item over 1 minus r. The first item equal to 30. 30 is the first item. R is the ratio between the second item and the first item. Second item, -15. First item, 30. So R equal to -1 over 2. Okay, so plug in A1 in S formula. A1 is 30. R is -1 over 2. So equal on the top it is 30, 1 plus 1 over 2 because negative is positive. So 30 over 3 over 2 because this one is 2 over 2. Okay, and then equal to 2 times 30 over 3. So equal 2 times 10 equal to 20. The final result 20 for question 8. Question 8 is 20. I want to turn on the light. Okay. All right. Questions? Okay. Okay, shall we do question 9? Question 9. Find the geometric sequence. So 9 -3 plus 1 negative blah blah blah. If you see this 3 dot without any item, that is infinite geometric sequence. Okay, and then you use the formula. Maybe I want to copy down. We are asked to do this. Okay, so first we need to use formula. The first item over 1 minus r. The first item is 9. R is the ratio between the second item and the first item. It is -3 over 9. It is -1 over 3. And then plug in A1, 9. R is negative 1/3. Negative is positive. And 1 is 3/3. So you can 4/3. And then fraction, this is 3 times 9/4. So equal to 27 minus 4. Okay, so this is this question. Any questions? All right, shall we go to next one? We did question 9. Question 10. Question 10. Find the fraction equal to the given decimal. So again, I will use a blank space to do this one. Question 10. Write down this number as fraction. That is the question. Okay, so question 10. Found the fraction, okay, to the given number. Okay, so let's do this. So first, let's decompose. Let's rewrite this number. This number is the same as 0.6 plus 0.09 plus 0.009 plus 0.0009 plus 0.00009 plus 0.9 and plus 0.9. So first of all, rewrite the number. Oops. Okay. And then what did you see for this part? This is infinite geometric series. Okay, so this part we can use A1 over 1 minus R, with A1 is 0.09, R is the ratio between the second item. We just talking about the sequence in this one here, okay, and the first item. So it is what is this? So 9/90. Okay, so it is 1/10. That is R. Okay, so keep on going. So copy down 0.6 plus use this formula. So A1 is 0.09 over 1/10. Okay, and our objective is change to fraction. So 0.6 is 6/10. 0.09 is 9/100. On the denominator, 1 minus 1/10 is 9/10. Okay, so keep on going. Copy down 6/10. And this one, both numerator, denominator times 10, still hold true. Okay, the reason for this is that 100 cancelled out, and you just have 9 over 90. 9 over 90. And 9 over 90 is the same as 1 over 10. So the final answer is 7 over 10 is the final answer. Questions? Questions? All right. So next question, that is question 10. Question 10. Question 11, write the first 4 terms for the sequence. So A1, you just plug in n equal to 1, you got A1. When n equal to 1, you got A1. So 1 plus 4, 1 plus 3, 5 over 4. That is A1. A2 means n equal to 2. So 2 plus 4 over 2 plus 3. So 6 over 5. A3 means n equal to 3. 3 plus 4 over 3 plus 3. 7 over 6. A4 means n equal to 4. 4 plus 4 over 4 plus 3. 8 over 7. Okay, questions? Right. Question 12. Wow, this one. Write the 99th term of the sequence. 99th term means n equal to 99. So you are asked to write down a subscript 99, plug n into 99. 99 plus 1, you got 103 over 100. Questions? Okay. Question 13. Write the first 4 terms and whose general term is given. So this is the general term. So A1 means n equal to 1. So A1 negative 1 raised to power 1, 4 raised to power 1. So negative 1, 5. So negative 1 over 5. So A2 means n equal to 2. Negative 1, 2. 4 raised to power 2. So 1 over 17. And then A3 equal to negative 1 raised to power 3. 4 raised to power 3 plus 1 equal to negative 1. 64. 64 is 4 raised to power 3. Negative 1 over 65. So A4 equal to negative 1 raised to power 4. 4 raised to power 4. So this is 1. So 64 times 4. 4 raised to power 4 is 256. So it is 1 over 257. Questions for question 13 and other questions? So next one. Question 14, found the genuine term of the sequence whose first 4 items agree with the given terms. So you get A1 is 2, or A1 is 10, A2 20, A3 30, A4 40. So what is the general term? There are many ways to do it. One way, you based on this formula, AN is the general term. AN equal to A1 plus N minus 1D. What is D? D is the difference between the second term and first term. The second term 20, the first term 10. So D is 10. Okay, and what is A1? A1 is given, is 10. And then you plug in this general formula, AN equal to A1 plus N minus 1 times 10. D is 10. So AN equal to 10 plus 10N minus 10. Then 10, negative 10 cancelled out. You have AN equal to 10N. This is your formula. Method 2, direct observation. If A1 is 10, A2 is 20, A3 is 30, A4 is 40, A5 is 50, A6 is 60, A7 is 70. If this is the pattern, so AN must be 10N. This is by direct observation. Okay. Okay, questions? This one a little bit difficult. Question 15. Look at the pattern and then predict the general term of the sequence. Okay. We can try use so this one, let me see. So first we have to find the pattern. How do we get from 5 to negative 12? And then how do we get from negative 12 to 19? One pattern is that it has a positive, negative, positive, negative. The sign is alternate. So positive, negative, positive, negative. So the first one is positive, negative, positive, negative. If this is the pattern, usually you have a negative 1 raised to power n plus 1. You have this one. Okay. This is one pattern we found, positive, negative, positive, negative. And then what other patterns do you observe? This sequence is not geometric sequence. It is not arithmetic sequence, because you cannot find the common D, you cannot find the common R. Okay. There is no common D, no common R. So this is another sequence. You can actually, this one pattern we observe is positive, negative, positive, negative. Then the other pattern you observe, if you use number 7 times the position of the term, means this is n equal to 1, n equal to 2, n equal to 3, n equal to 4. This is 1, 2, 3, 4. Okay, this is n equal to. So how does each number relate to the position? The first number, second number, third number, fourth number. Okay. So for example, how do you get number 5? Number 5 in position 1. So number 5 could be 7 minus 2. And 7 could be 7 times 1. Okay, 1 is n. And how do you get 12? 12 could be 7 times 2 minus 2. And how do you get 19? 19 could be 7 times 3 minus 2. Okay, and how do you get 26? 26 is 7 times 4 minus 2. So this is another pattern we observed. So the number inside the bracket indicate the n. So generally speaking, you have 7 times n minus 2. Okay, so this is the general term. And plus the positive, negative is controlled by this one. So the final answer, you got this one here. That is the general term for the sequence. By the way, this sequence is not an arithmetic sequence. This sequence is not a geometric sequence. This is just a normal, regular sequence. Arithmetic sequence and geometric sequence are special form of sequence. Any questions? So can you predict the next number after negative 26? Can you predict? Anyone? The next number must be positive number. And the next number in position 5. So you use 7 times 5 minus 2. So 7 times 5 minus 2. You got 33. So this is the negative number. Next number, okay, in position 5. And then how do you get the number in position 6? You use 7 times 6 minus 2 equal to 40. But the next number must be negative. So it should be negative 40 is the next number. Okay. So let's predict next one. Next one is 7 times 7 minus 2, 47. And it is positive number, 47. And the next number must be negative after 47. So that number would be 7 times 8 minus 2, 54. So negative 54 is here. Okay. I go to questions. 33. Thank you, Mayura. Yeah. Okay, you are correct, Mayura. Congratulations. It is 33, position 5. Okay. All right. Any questions? Okay. The rest of this question is multiple choice. You can do by yourself. And this one is also multiple choice. I give you the answer. We did similar question for this one. We still have a lot of questions. Shall we take a 10 minutes break? After break, we can continue the rest of the question. Okay, so after break, we will do question 16. Okay, okay, everyone break back at 8 o'clock. We can do the question together. All right, welcome back. Hope you have a nice break. Before break, we did it up to question 15. Any questions? Okay, now shall we continue? So question 16. Determine whether the sequence can be the first three terms of arithmetic geometric, and if so, find the common difference or common ratio under the next two terms of the sequence. So let's do question A. Is it arithmetic or geometric? Anyone? So you have 14, 9, 4. So if you use 9 minus 14, second item minus first item, you got -5. And then use 4 minus 9, you got -5. So it looks like this is an arithmetic with the common fact difference D equal to -5. Okay. So the sequence is geometry common difference of -5. Right, this is A. The next two terms are, so generally formula, so you write down AN equal to A1 plus N minus 1D. So this is, we are asked to find A4 and A5. So A4 equal to A1. A1 is 14. N is 4. So 4 minus 1 times D. D is -5. So equal to 14 plus 3 times -5. So -1 is the A4. Okay. So the next item is -1. I'll double check. Okay, so next item is -1. Okay. And then we also need to find A5. So A5 is A1 plus 5 minus 1 times D. D is -5. So it is 14 minus 20. It is -6. So after -1, you got -6. Okay. Questions? Okay, let's do B. -3, 9, -26. So B. Oh, this. So the A we select for this one. Okay, this is multiple choice question. So we are looking at B. So B is, so if you use 9 over -3, you got -3. If you use negative 27 over 9, negative 3, so this is geometric sequence with common ratio R equal to negative 3. So B, where is B? So this sequence is geometric with common ratio negative 3. It is geometric sequence. The next two terms, so the correct answer is this one. So the next two terms, so we use the formula for the geometric sequence. So AN equal to A1 R raised to power negative 1. That is the general formula. So A1, so right now we are asked to figure out what is A4, A5. So A4 equal to A1. A1 is negative 3 times R. R is negative 3 raised to power n minus 1. N is 4, so raised to power 3. So it's going to be negative 3 times negative 27. So negative negative is positive 81. So this is A4. And we are also asked to provide with A5. So A5 is A1. A1 is negative 3 times R raised to power 4. So negative 3 times 81. So negative 243. Okay. So questions? Okay. So now let's do question C. 3, 7, 11. Looks like it is arithmetic. Difference is 4. Okay, 7 minus 3 is 4. 11 minus 7 is 4. So C is arithmetic sequence. So C is arithmetic sequence. C is arithmetic sequence with common difference D equal to 4. The next two terms are, so for arithmetic sequence, AN equal to A1 plus N minus 1D. So the next two terms is A3, no, A4, A5. A4 equal to A1. A1 is 3, D is 4. A1 is 3. So 4 minus 1, D is 4. Check. Yeah, 4. So equal to 3 plus 3 times 4, 15. And A5 equal to A1 plus 5 minus 1 times 4, 19. So that is the C. And then for D, D is arithmetic D, because when you do 1 over 12, this is second item, over the first item, you got 4 over 12, you got 1 over 3, and then when you do 1 over 36, this is the third item, over 1 over 12, you go to 12 over 36, so still 1 over 3. So 1/3 is the common ratio R. D is a geometric sequence. So let's go for D. D is a geometric sequence with common ratio D with common ratio 1/3. Okay. And the next two terms are, so AN equal to A1 times R raised to power N minus 1. So the next two terms is A4, A5. A4 equal to A1. A1 is 1/4. R is 1/3 raised to power 3. So the next term would be 1/4 times 1/27. So equal to 1/108. This is A4. And A5 equal to A1 R raised to power 4. So 1/4. 1/81. And again, it is 1/324. Okay. Questions? All right. So next question, question 17. Question 17. Determine whether the finite series is arithmetic, geometric, or both, or neither. If it is geometric or arithmetic, find its sum. So 28, 27 plus 3. The difference between second term and the first term is negative 0.7. And then the difference between the third term and the second term is also negative 0.7. Okay, so this is arithmetic series. So we need to find the sum. So the sum is S arithmetic. But first of all, the last item is 0.7. We need to find how many items there. This is 1, 2, 3, and how many total items? Okay. So we write down the general term. Remember, AN equal to A1 plus N minus 1 times D. D is negative 0.7. D is negative 0.7. Okay. And then we know there is a term 0.7. So 0.7 equal to A1. We know A1 is 28. 28. And we want to solve for N. We know D is negative 0.7. The reason we want to solve for N is we want to find the sum of this series. In the sum formula, you need N, term N. Okay, so far we got one equation, one unknown here. So we just need to solve for N. So left-hand side, right-hand side simplify. So negative 0.7N plus negative, or plus 0.7. And then collect like term, move this negative 0.7n to left-hand side. Right-hand side, you have 28 plus 0.7 minus 0.7. So 0.7n equal to 28 times 10 on both sides, 7n 280, n equal to 40. There are 40 items. Okay, and once we found n equal to 40, we then use formula S equal to the first item minus the last item. Okay, this is one formula. There is another formula. Okay, so we know n equal to 40. The first item is 28. The last item is 0.7. Okay. And then this is going to be 20 times 28.7 and equal to 574. 20 times 28.7. Questions? Okay, question 18. Let A1, A2, A3 be arithmetic sequence. Found A24 as 34. You are given the first item and the common difference D. So A24 is just A1 plus n minus 1 D. A1 is 7, n is 24, D is 2. So 7 plus 23 times 2, 53. That is A24. Okay. And then you also need to find S34. Okay. For S34, we can use another formula. I'll show you at the beginning. Okay, here. For S34, arithmetic sequence. So we can use this formula, but we have to solve for A34. So instead, if you don't want to solve for A34, okay, I will do this. I will divide this formula. There's another formula without using A34. Where we are. Okay, we are here. Questions. Remember the formula for is n over 2 a1 plus an, and then an equal to a1 plus n minus 1d, right? That way we do not need, we just need to use n, a1, and d to find s. So this formula would become 2a1 plus n minus 1d. And then we use this formula to find S34. So S34, n equal to 34. 34 over 2 times 2a. A is 7 plus n minus 1. N is 34. Minus 1 times d. D is 2. Okay. And then equal to 34 over 2, 14 plus 33 times 2, 66. And equal to 14 plus 66, 80. And then this becomes 40. This is the final answer. Okay, S34. Questions? All right. Question 19. Let A1, A2, AN be a geometric sequence found A4. So A1R is given. What is A4? Okay. So let's try AN equal to A1 times Rn minus 1. So A4 is A1. A1 is given 8. R is given -3. N is 4. Okay. So 8 times -3 raised to power 3. So 8 times -27. So it's going to be -216. So this is question 19. Okay. Oh no, not from here. This is the other question. Question 19, we started from here. Yeah, this belongs to previous question. Okay. Questions? Okay, question 20. Question 20, A1, A2, A3, AN be geometric sequence found S10 and S infinity. So S10. So Sn, we use this formula. Remember, we just found this formula. Sn equal to n over 2, 2A1 plus n minus 1D. That is Sn. So S10 equal to 10 over 2, 2A. A1 is 500. N is 10. Oh, this is geometric sequence. Sorry. We need to use formula for geometric sequence. I used the arithmetic formula. We use geometric sequence for Sn equal to A1, 1 minus R, N, N minus 1 or N divided by 1 over R. I'll double check on the beginning. I have the formula here for geometric sequence here. Geometric sequence Sn equal to A1, 1 minus Rn over 1 minus R. So this is for this one. So go back to our question. So this is the formula for geometric sequence, the sum of geometric sequence, Sn. So S10 equal to A1. A1 is 500. 1 minus R. R is 0.5. N is 10. Divided by 1 over 0.5. So equal to 500 times 1 over 0.5 raised to power 10. On the bottom, 1 minus 0.5 is just 0.5. And 0.5 is the same as 1 over 2. 1 over 2 is 0.5. And then 2 times 500 is 1,000. 0.5 raised to power 10. You can use your calculator to do that. I will use Excel. So 1,000 times 1 minus 0.5 raised to power 10. So I'm going to do 1000 times bracket 1 minus 0.5 raised to power 10. Okay. So I get 999.02. Okay. So I just use Excel. 0. So this is the result from Excel. Okay. So we found S10. Next, found S infinity. So the formula for S infinity is just the first item over 1 minus R. The first item is 500. R is 0.5. So this becomes 500 over 0.5 equal to 1000. Okay. So this is question 20. Questions? Okay, question 21. Multiple choice questions. If R equal to 1, neither the first form nor the second form for the sum of geometric series is valid. Find the formula for sum of the finite geometry. If R equal to 1, that's interesting question. So if R equal to 1 means second item over the first item is 1, means second item equal to first item. So all the item equal to the first item when R equal to 1. Okay, and then sum of all of this naturally becomes A1 plus A1 plus A1 plus A1 plus. So how many A1? You have N A1. So this is the formula. Okay. Because the R common ratio is 1. Every item is the same as the first item. When you add such series, it is just N times the first item. Okay, questions? And this is here. This belongs to the previous question. Okay, last question. Oh no, 2 more. Yeah. 23 is our last question. 22. Does there exist a finite arithmetic series with A1 is 1, AN is 1.1 that has a sum equal to 100? Can you find an arithmetic series? A1 is 1, AN is 1.1, and the sum is 100. We can assume if it is a series, we can calculate. Remember, if it is arithmetic, the AN equal to A1 plus N minus 1D, right? So AN is 1.1, A1 is 1, okay. And then we don't have D, we don't have N, we can just write down here. And that have a sum is 100. So Sn equal to A1 plus AN. So it is 100 2n, a1 is 1, an is 1.1. Okay, so this is based on this sum. And then we can solve for n from this one here. So 200 equal to n times 2.1. You cannot get n. N is not an integer. N is not an integer. That's why it is not an arithmetic sequence. So because n use formula. Sn, we did use this formula here, we solve for n. N is not an integer. Okay. So this is the question 22. Questions? Okay, question 23. Does there exist infinite geometric series with A1 is 10 that has a sum equal to 6? So remember geometric sequence, infinite sum equal to first item over 1 over r. So the sum is 6. The first item is 10. And then 1 minus r, we solve for r. So 6 minus 6r equal to 10. 6r equal to 6r equal to -4. So r equal to -4 over 6. So 2 over 3. We get this r is -2 over 3. So yes, there is infinite series. Okay. So this is our last question. Any questions? Okay, in summary, we did geometric series and arithmetic series. In both situations, we write down the formula for general term an and for the sum s. Okay, so that is what we have done today. Any questions? Thank you so much for your participation, for your understanding, and for your patience until the last minute. I appreciate your dedication and your participation. And remember, you can always email me for any questions. When you email me, please allow 2 business days to have your email answered. Okay. If there is no question, I will close the meeting. Thank you again. Good night. Bye. Yusuf, do you have questions? I will stop recording first. Stop recording.